Good morning all. Our next section is Mossbauer spectroscopy. We have already seen what is meant by ESR spectroscopy and NMR spectroscopy, and we know what is meant by the resonance absorption. Now we are discussing about the Mossbauer spectroscopy. In Mossbauer spectroscopy, we are studying about the gamma ray emission from excited nuclei and its subsequent reabsorption by other nuclei. As in the case of ESR and NMR, here also there is a resonance absorption. Now, the resonance absorption is due to the gamma rays. Here it is due to gamma rays and are emitted from an excited nuclei. That is the difference. That is, in Mossbauer spectroscopy, we have a gamma ray emission from where? From an excited nuclei, and it is absorbed by another nucleus and the resonance happens. The resonance condition happens. So, in Mossbauer spectroscopy, we are dealing with the transition between the energy levels of nuclei of atoms, and it is observed by Mossbauer in 1958. The graph shows the nuclear resonance absorption. You have a nucleus in the excited state, and when it comes to ground state, there will be a gamma ray emission, and this gamma ray is absorbed by another nucleus, and there will be some resonance condition, and this represents this nuclear resonance absorption. Now, for that purpose, you consider an isolated atom. You consider an isolated atom in the ground state E0 with a nuclear excited state of energy E and ground state E0. Consider an isolated atom having ground state energy E0 and excited state E. Suppose that there is a transition from the excited state to ground state, then there is a photon is emitted. Here it is gamma ray is emitted. The energy of the photon, that is h nu. So, please remember, if there is a transition from the nuclear excited state E to a ground state E0, there is an emission of gamma ray with energy h nu. Now, let us consider the emission part only, and we will discuss the absorption part later. Now, what happens when there is an emission? When there is an emission happens, the nucleus will recoil. Whenever there is an emission from a nuclear excited state to ground state, the nucleus will recoil. The nucleus will recoil means it has a kinetic energy of recoiling, is it? It has a kinetic energy of recoiling. So, we can represent it as half mv square. If m is the mass and v is the velocity of the nucleus, then this half mv square represent the recoiling of the nucleus. So, remember, whenever there is a transition from the nuclear excited state to ground state, the gamma ray emission happens, and during the emission of the gamma ray, the nucleus will recoil, and the recoiling nucleus has a kinetic energy that is given by ER equal to half mv square. So, when the gamma ray is emitting and the nucleus is recoiling, and during the entire process, the energy should be conserved and the momentum should be conserved. Now, if we consider the conservation of linear momentum, then we can say that the momentum of the photon must be equal to the momentum of the recoiling nucleus. What is the momentum of the photon? The photon has an energy h nu, so its momentum is h nu by c, and the momentum of the recoiling nucleus is mass into velocity. Also, from the conservation of energy, the difference in the energy between the two level E minus E0, this is equal to h nu, the energy of the emitted photon, plus the recoiling kinetic energy of the nucleus. So, you can write it as h nu plus half mv square. Now, let us rearrange the term half mv square as half into mv whole square by m, and from here your mv is nothing but h nu by c. So, if you write the expression like this, you will get an equation E minus E0 equal to h nu plus half h square nu square by mc square. Now you just compare the equation we have written above. We can say that we have an equation of the form h nu plus er, and we get an equation of the form h nu plus half h square nu square by mv square, and comparing these two equations you can say that your nuclear recoiling kinetic energy is equal to h square nu square by 2mc square. This is the kinetic energy of the recoiling nucleus when it emits gamma ray. Er equal to h square nu square by 2 mc square is the kinetic energy of the recoiling nucleus. Now, if you go through the previous equation, that is h nu equal to E minus E0 minus Er, we can say that the kinetic energy of the emitted photon, that is the energy of the emitted photon h nu, which is less than E minus E0, which is less than the energy separation between the excited state and ground state by an amount Er. What is Er? Er equal to h square nu square by 2 mc square. So we can say that the kinetic energy of the emitted photon is less than E minus E0 by h square nu square by 2 mc square. Now our first part is over. There is an emission from the nuclear excited state to there is an emission when there is a transition from the excited state to ground state. Now what happens when the same gamma ray is absorbed by another nucleus? What happens when the emitted gamma ray is absorbed by other nucleus? Of course, when the gamma ray is absorbed, there is a transition from the ground state to excited state of the other nuclei. So there will be some resonance condition. So in the process of this resonance absorption, the radiation, the gamma ray is absorbed. Remember, the gamma ray is emitted by another nucleus. So what happens when this gamma ray is absorbed by another nucleus? We have already seen that whenever there is an emission, the recoiling of nucleus happens. The same thing happens when the nucleus absorbs this gamma ray. When the nucleus absorbs the gamma ray and try to go a transition from lower state to upper state, then there also this recoiling happens. And for that purpose, the atom uses the same amount of energy, that is the recoiling kinetic energy, h square nu square by 2 mc square. So a part of the photon that is absorbing is utilized for the recoiling. Then it undergo transition. So the energy of the photon available for absorption is h nu minus 2 times Er. What is Er? Er is the recoiling kinetic energy of the nucleus. This expression is h square nu square by 2 mc square. Here, as in the case of ESR and NMR, we have a condition for resonance absorption. What is the condition for resonance absorption? The natural width of the excited level should be more than 2 times Er. If Er is the recoiling kinetic energy of the nucleus, then the natural width of the excited level must be more than 2 Er. Then only the resonance absorption happens and you will get a spectrum.